here we simply use one simple example to show how to create X bar chart and R chart for statistical quality control purposes using Excel. So please open the example dataset provided here. In this example, we say we randomly select 5 samples. Each sample has the same sample size equals 4. So suppose what we collected or measured are the minutes used. Suppose we are measuring the process of preparing a hamburger at a fast food restaurant. So we randomly select 5 samples from, let's say, 5 days. We randomly select 4 times 4 hamburgers and just calculate record how many minutes it takes for them to prepare the hamburgers. So in that case, we know our sample size equals 4. Or you can use the count function to count how many observations carried each sample. And then the sample mean. So please pay attention, there are 2 different formulas for X bar here. So first formula, we are using standard deviation cases. And the second one, so sometimes people would like to use the average of the range to calculate the up control limit and the lower control limit for the X bar case. So let's first stick to more often used control limit calculation formulas here. In this formula, Z stands for how many standard deviations away from X double bar. This is the overall sample mean level. It's a central level here. So suppose it's given that Z equals 3, which equals a 99.7% control level. And of course, we can assign different control levels. We will show using Excel. It's very straightforward to calculate those kind of values. So let's coming back here. So first of all, we are calculating the sample mean, those X bars. And also for each sample, you know, there's a range. The range simply equals the difference between the maximum value and the minimum value. So you can use max function minus minimum function, or you can simply use the range function in Excel. So for 5 samples, we calculate for each sample the sample mean X bar and R value, and overall mean level X double bar. Simply take the average of all these sample means of all these X bars, or you can simply highlight the whole range of all data, all sample data pulled together. And then to calculate the up control limit and the low control limit, of course we need to know standard deviation value and also the Z value here. So standard deviation of X bar, also it's called the standard error. So it simply equals the standard deviation of the population of the sample values obtained. Suppose we do not have any information, we do not know the value for the whole population standard deviation. In that case, we use sample standard deviation and divide by square root of the sample size. So coming back here, STDEV stands for standard deviation, the sigma. So if it's given, we just load the given value here. Suppose it equals 2, you simply type 2 here. Otherwise, we use STDEV, standard deviation function in Excel. And based on put all sample values together to calculate the standard deviation, a point estimate for the population standard deviation case. And then the standard error simply equals standard deviation divided by square root of sample size. So which in our case here equals to square root of 4. And the z value, if it's stated that we are construct a 3 sigma X bar chart here, then simply type 3 here. Otherwise, based on different control level. So in our case, 3 sigma, if z equals 3, it relates to the control level of 99.7%. Otherwise, suppose we say, sometimes people say, I simply want to construct a X bar chart using based on control level of 95%. So 95% simply means since we are using a normal distribution case, so it's symmetric. Simply it means so we have up control limit here and the lower control limit here. So the area under the curve between these two bounds equals 0.95 or 95%. Since it's symmetric on both sides, it equals 1 minus 95% divided by 2. So also, which means cumulative probability of the area under the curve from negative infinity up to this up control limit value here equals 97.5%. So just pay attention. This relates to the basic business statistical material. So we say it's similar to the alpha level, significance level in statistical hypothesis test cases here. So which means alpha equals 1 minus this value. So divided by 2 on both sides for the error case. So z value, it equals norm S, stands for standard normal distribution. Probability equals 1 minus this alpha divided by 2, which will return a z value of 1.959964. So pay attention. In this case, suppose we are using sample standard deviation to construct our upper control limit and the lower control limit. So the upper control limit for the X bar simply equals X double bar plus z value multiplied by standard error. And lower control limit for X bar case, it equals X double bar minus z value multiplied by standard error case here. So now we can construct the X bar chart using all the information here. And of course we say we try to use Excel to construct the calculations to construct a chart, because in which case it's simply very straightforward. We can change the control level, suppose 99% control level. So all the final this kind of control limit values will change accordingly. So let's still come to 95%. And using sample standard deviation, first of all, the central line coming here, central line is X double bar. So simply equals its value, but we fix its position. So we have, let's say, example 1, 2, 3, 4, 5 in our case here. And our example mean x bar here, or we can type example mean level simply equals the value in this row here already calculated. So let's select this one and simply transpose this row to be a column. And then upper control limit, lower control limit. So up control limit, its value locates in the cell here. Also fix its position. Then lower control limit, so with all this information, these 4 columns, simply use a line charts in Excel to create the X-bar chart using sample standard deviation. And of course, you will see you can modify the chart, like by changing the chart title to be X-bar chart using sample standard deviation. And also, of course, if we want to see more clear, we can put a mark here for the sample mean level. So let's using triangle. And also at axis title, we are more interested in, let's say, horizontal. Examples, or simply state example 1, 2, 3, 4, 5. So based on this X-bar chart using sample standard deviation, we say all the sample means the process is under control based on statistical control theory here. So there's no sample mean locates outside of either bounds, upper control limit bound and the lower control limit bounds. Okay, this is one thing here, and then also another formula for constructing the X-bar chart is using the range of the samples. So in this case, it's based on the assumption that we are only constructing 3 sigma level, control level X-bar charts. And A sub 2 is a factor. Its value can be found in the table. So based on different sample size, in our case, our sample size equals 4. So A sub 2 factor value equals 0.729. So we can simply calculate here. Let's say it equals X double bar plus 0.729 multiplied by an R bar. R bar here, yeah, we are not we didn't calculate that yet. So simply say we put R bar in this cell. So simply R bar equals average value of all sample range. So accordingly, the lower control limit equals X double bar minus 0.729. Let's double check the factor value multiplied by R bar. So you will see all these values change automatically. and also the control charts also change accordingly. The only thing we need to change is simply the title. So now it's also X bar chart, but we are using the average range, the R bar value here. Based on this control charts, also we say it's under control, under statistical control. There's no value locates outside of the bounds. Also, there's no obvious pattern. Let's say if we have all 5 sample mean locates consistently, or it's increasing pattern, decreasing pattern, or different patterns, then it signals we need to conduct additional investigation to see what exactly bring those kind of pattern to show up. Okay, this is a X bar chart to check the average level, see whether it's under control. But also in statistical control, quality control theory, we need also to check, not only by checking the sample mean level, but also we want to check whether the variability is under control. Because generally speaking, let's say we have different cases here. So for one case, if we observe such kind of pattern, and another one we observe like this, the mean level are the same. So using X bar, we make the same conclusion that it's under control. But the variability definitely shows that the first shift, let's say we are conducting statistical quality control to analyze the quality, analyze the working performance, like for fast food, the food processing time. In which case, definitely it shows that the first shift has some kind of problems there. You need to investigate, conduct additional analysis to see what brings such kind of the variability, the huge volatility in the processing times used. But for the second shift, then it seems very consistent. So there's no obvious things for us to worry about the quality issue here. So that's why in statistical quality control, normally we combine X bar and R bar, the range bar chart, together to check the quality issue. So in dealing with the R chart, we are using the formula listed here, also in your textbook. So it's simply we calculate up control limit, which equals R bar, the average range multiplied by a factor D sub 4, and the lower control limit is R bar multiplied by D sub 3, and the D sub 3 and D sub 4 also listed in the table here. Based on the specific sample size, we found that in our case here, D sub 4 equals 2.282 and D sub 3 equals 0. So let's come in here, we say D4 equals 2.282 and D3 equals 0. So up control limit for the R chart simply equals D4 multiplied by R bar here. And lower control limit equals D3, which is 0, multiplied by R bar, also it equals 0. So let's type the formula in the completeness. Then we say, for example, 1 to 5, sample range we already calculated in the row here. And R bar corresponding up control limit, lower control limit. So R bar equals 0.52. Also, we fix its position, press F4 key, up control limit, press F4 key again, then lower control limit equals 0, press F4 key. So now simply plot these 4 columns into a line chart here. So insert lines. So you will see. Also, of course, you can change the title to be R chart and put the title for the axis here, for the horizontal axis, for example, and put here for the range, the title, and then also you can add the mark. Very often in real analysis case, you have to add marks there for us, for other people to identify the issue very clearly and very easily. So based on our charts here, also the variability is under control. So there's no worry based on statistical quality control theory for our case here, for this example. So these are typical procedures, how to construct the R chart and R charts using Excel.